Find the value of the ratio and x in the given figure. Line constructions, properties of rectangle, Pythagoras theorem, basic arithmetic and algebraic processes are used to solve this question. Label points B, C, and D. Also, label centers of the circles O, G, and K. Join line OG, line DG, line OC, and line BG. This implies that OD equals OC minus CD, which equals to r minus small r, since CD equals BG, which equals to small r. Also, line DG equals 10, since line DG equals line BC, which equals to 10. By Pythagoras theorem, the square of OG equals the sum of the square of OD and the square of DG. Substitute values. We have that the square OG equals the sum of the square of r minus small r and the square of 10. We call it equation 1. Join line G, K, and line O, K. It follows that G, K equals 2 times small r, which equals to x. It is because opposite side lengths of a rectangle are equal. Also, each vertex angle of a rectangle equals 90 degrees. It signifies that angle GKO equals 90 degrees. Line OK equals the sum of small r and r. Triangle GKO is a right triangle. Using Pythagoras theorem, the square of OG equals the sum of the square of OD and the square of DG. Substitute equation 1 and we have that the sum of the square of r minus small r and the square of 10 equals the sum of the square of r plus small r and the square of 2 times small r. Since line OK equals the sum of small r and r, as shown on the screen, it is because opposite side lengths of a rectangle are equal. Each vertex angle of a rectangle equals 90 degrees. Hence, the sum of the square of r minus small r and 100 equals the sum of the square of r plus small r and 4 times the square of small r. We call it equation 2. Label point J and join line OJ. OJ equals a minus small r and join line JK, where line JK equals 8 units. It is because opposite side lengths of a rectangle are equal. Using Pythagoras theorem, the square of OK equals the sum of the square of OJ and the square of JK. Substitute values into the equation. The square of the sum of r and small r equals the sum of the square of r minus small r and the square of 8. We call it equation 3. Solve equation 2 and equation 3. That is, the sum of the square of r minus small r and 100 equals the sum of the square of small r plus r and 4 times the square of small r, which we called equation 2. Also, the square of the sum of small r and r equals the sum of the square of r minus small r and the square of 8, which we called equation 3. Expand brackets of equation 2. We have that the square of r minus 2 times the product of r and small r plus the square of small r plus 100 equals the square of small r plus 2 times the product of r and small r plus the square of r plus 4 times the square of small r, as shown on the screen. Simplify further so that the sum of the square of small r and r times small r minus 25 equals to 0. We call it equation T. Also, from equation 3, the sum of the square of small r and 2 times the product of r times small r plus the square of r equals the square of r minus 2 times the product of r and small r plus the square of small r plus 64, as shown on the screen. Cancel equal but opposite sign terms in the equation and simplify. Combine like terms and divided the equation by 4 times small r. We have that r equals to 16 divided by small r, after simplification. We call it equation Z. Substitute into equation T. This implies that the sum of the square of small r and small r times 16 divided by small r minus 25 equals to 0. Simplify to obtain an equation shown on the screen. That is, the square of small r minus 9 equals 0. Make the square of small r the subject of the equation and find the square root of the new equation. We obtained that small r equals plus or minus 3. Small r is not equals to negative 3. The reason is that length measuration has no negative value. It implies that the value of small r, which is the radius of the congruent small circles, equals 3 units. Substitute into equation Z. It follows that r equals 16 divided by small r, which equals to 16 divided by 3 in units. Finally, the required value of the ratio r divided by small r equals 1/3 of 16 divided by 3, which equals 16 divided by 9, as shown on the screen. Therefore, the value of the ratio r divided by small r equals 16 divided by 9.